Hi all, welcome to TutySpot. In this video, let's discuss about recognition of tokens in compiler design. We already discussed in the earlier videos that the tokens are the smallest meaningful units of your programming language created by the lexical analyzer from a stream of source code characters. They represent various elements like keywords, identifiers, operators, constants, and special characters which are then passed to the syntax analyzer. These tokens are specified using strings, languages, and regular expressions. Coming to the matter of recognition of tokens, these tokens are recognized using transition diagrams. So let's have a brief look into the topic. We have 5 different ways for recognizing the tokens. They are: first one is recognition of identifiers, second one is recognition of delimiters, third one is recognition of relational operators, fourth is recognition of keywords, fifth is recognition of numbers. Let's see one after the other and draw the transition diagrams. So first is the recognition of identifiers. Usually identifier starts with a letter followed by any number of letters or digits. In Pascal language, underscore is not necessary. If we use C language, then we have to use underscore. So the regular expression for this will be letter produces A or B and so on up to Z, and we can also use uppercase letters like A or B and so on up to Z. And digit produces 0 or 1 or 2 and so on up to 9. And identifier ID produces a letter followed by any number of letter or digit, including star for 0 or more occurrences for this letter or digit. So let's start the transition diagram. Where initial state is 0, we have to draw arrow point to every state in the diagram. If we apply letter on state 0, then we will get the state 1. And if we apply any number of letters or digits on state 1, we can apply the self loop and it is the final state. Final state is denoted by double circle symbol. Suppose take an example A, B, C, 1, 2. Initial state is 0 and A is applied as letter on state 0. Then in state 1, we can apply any number of letters or digits. So we applied B, C, 1, 2. And 1 is the final state here. And the second is recognition of delimiters. A delimiter can be a white space or tab space or new line character that is present between two words. So the regular expression for this will be the word space WS produces delimiter followed by another delimiter with 0 or more occurrences. So let's start the transition diagram starting with a delimiter applied on state 0 followed by any number of delimiters applied on state 1, and it is the final state. And the third is recognition of relational operators. Greater than or equal to, less than or equal to, double equal to, or not equal to comes under relational operators. So let's start the transition diagram where 0 is the starting state or initial state. First apply greater than on state 0 and it denotes the state 1. Then apply equal to on state 1 and it produces the final state 2. We have operator greater than without applying equal to. So there is no need of state 2 to apply only greater than. Then we have to apply other symbol on state 1. Then it will produce the state 3 which is the final state. In the place of other we can write any digit or letter like A, B, 1, 2, like greater than A, greater than 1, likewise. To note the token information, the syntax will be within the braces token name, attribute value. Here the token is taken as relational operator RELOP and the attribute values are GE for greater than equal to and GT for greater than. Next follow the same process for less than and less than equal to produce state 4, 5 and 6. Apply less than on state 0 to produce state 4 and equal to on state 4 to produce state 5 and it is the final state, and apply other on state 4 to produce the final state 6. So they produce the tokens with the names relational operator RELOP, LA for less than or equal to and LT for less than. Next do the same process to apply equal to on state 0 to produce state 7 and other equal to produce the final state 8. Then the token will be relational operator RELOP and double equal to is denoted by EQ. Next apply not symbol on state 0 to produce the state 9 and equal to symbol on state 9 to produce the final state 10. Then the relational operator will be RELOP and not equal to is denoted by NE. And the fourth is recognition of keywords. Usually we have many keywords like if, else, while, for and many more. Let's take if, else and for here. So let's start with the starting state 0 and draw the transition diagram. So let's start with if I is applied on state 0 to produce state 1 and f is applied on state 1 to produce the final state 2. So if is completed. Next else E is applied on state 0 to produce state 3, L is applied on state 3 to produce state 4, S is applied on state 4 to produce state 5 and E is applied on state 5 to produce state 6 and 6 is the final state. Next for F is applied on state 0 to produce state 7, O is applied on state 7 to produce state 8 and R is applied on state 8 to produce the state 9 and 9 is the final state. And the last is recognition of numbers. We have both integer and floating point numbers. Numbers like 1, 2, 3 are considered as integer numbers and numbers with fraction or exponential notations are considered as floating point numbers such as 123.456. It is a fractional and 123.45 E67. E is the exponent. 1, 2, 3 as integer and 4, 5 as the floating point number. E can either be positive or the negative value like 123.45 E plus 67, 123.45 E minus 67. So our regular expression should satisfy all these strings. So let's write the regular expression for this. First, digit means we have 0 to 9 values and digits means a digit followed by any number of digits from 0 to many occurrences. So the regular expression is number produces digits within the braces dot digits question mark and within the braces E plus or minus question mark digits braces close question mark. Here question mark represents 0 or more occurrences of that combination. That means if we apply question mark in the syntax of regular expression, that occurrence present before the question mark can be applied once or we can neglect that operation to occur. So let's observe it with previous numbers we took. We have 1, 2, 3. So all the digits are satisfied. And next is 123.456. So 123 as digits here and dot and 456 at digits here. And the remaining syntax has question mark, so it is negligible. Next we have 123.45 E plus 67. So digits 123.45 digits E plus or minus is there, so plus or minus and digits 6, 7. So the syntax is satisfied and the regular expression we wrote is correct. So let's see the transition diagram starting from state 0. Then apply digit on state 0 to produce the state 1. On state 1 we can apply any number of digits as self loop. Then apply dot on state 1 to produce state 2. Then apply digit on state 2 to produce state 3. And we have digits here. So apply digit as self loop on state 3. Up to here the syntax is satisfied. And next E. Apply this E on state 3 to produce state 4 and plus or minus on state 4 to produce state 5. And then digits. A digit on state 5 to produce state 6 and remaining digits as self loop and other on state 6 to produce the final state 7. So the regular expression is satisfied up to here and we got these two expressions means 1, 2, 3 dot 4, 5 E plus 6, 7. So this is satisfied and 1, 2, 3 dot 4, 5 E minus 6, 7. So this one is also satisfied. And the remaining we have are 123, 123.45, 123.45 E67, 123 E67. So up to now the transition diagram is completed if we choose to have all the occurrences. Now if we don't need some occurrences, we can modify the transition diagram. If we want only digit, then at state 1 we can produce state 8 as the final state. Take for example 1, 2, 3. 1, 2 and 3. So this is also satisfied. So the remaining are 123.45, 123.45 E67, 123 E67. We can move to state 4 from state 1 if we neglect dot and digits by applying E. then the expression will be 1, 2, 3 E plus 6, 7 or 1, 2, 3 E minus 6, 7. And if we want only digits, then we can add state 9 at state 3 as the final state by applying other than digit. Then take the example 1, 2, 3 dot 4, 5 and final state completed. So this is also satisfied. And the remaining are 1, 2, 3 dot 4, 5 E6, 7 and 1, 2, 3 E6, 7. And if we don't need to apply plus or minus, then we can apply digit on state 4 and can go to state 6. So take for example 1, 2, 3 dot 4, 5 E and 6, 7 or 1, 2, 3 and then E and then 6, 7. Likewise, all the possibilities are satisfied from this expression. This is all about the recognition of tokens. Hope you understand. Thank you.